In this video, we will talk about the first application of the derivative that we're going to look at, and that is finding equations of tangent lines. So the basic problem is to find, given a function f of x that's differentiable at some number a, in other words, the derivative exists at that point, what we want to do is find an equation of the tangent line at that point, a comma f of a. So here's just a picture of kind of what's going on here. We have the graph of the parabola here, and here's a point on the graph of that parabola that's at the coordinates 1 comma 2 here. And then here we can see the tangent line graphed out in red. So the tangent line just kind of comes and skims in here. So given the equation for the function, the blue graph here, and a point on the graph, then find the equation for the tangent line at that point. So the first thing that you need to recall is the point slope form of a line from algebra class. And there's a typo there. If x1, y1 is a point on a line and m is the slope of the line, then the equation y minus y1 equals m times x minus x1, right, is an equation of the line. Okay, so if I have a point x1, y1, then I will just plug whatever the x coordinate is in here for x1, the y coordinate for whatever is here in y1, and the slope, plug it right in there, and that will give me an equation with x and y, right? And if I graph that equation out, that's the equation of the line. Okay, so we're going to use that fact to find the equation for the tangent line. All right, so if we want to find the equation of the tangent line to the graph of f of x at some point a comma f of a on the graph, right, we're going to start with the point slope form of the line. Y minus y1 equals m times x minus x1. Okay, and we know two things, right? First off, the tangent line has to go through that point, right? The tangent line touches that point on the graph. So a comma f of a is a point on the tangent line that we're looking for. And also the derivative at a, right, in symbols, the symbol for that is f prime of a, right? Remember, the derivative is the solution to the tangent line problem. In other words, the derivative gives the slope of the tangent line at any point on the graph. So now we know a point on the line and we know the slope of the line. So we can substitute those values into the point slope formula and get the equation that we want here. Okay, so the point on the line is a comma f of a. So I just simply put a in here for x1. And the y value, f of a, whatever the value I get when I plug in a into the function, that gets plugged into y1. Okay, and then the slope of the line, well, that's just given by the derivative of the function at the number a, so f prime of a. So this is the formula for the tangent line. Okay. All right, so let's look at an example. So find the equation of the tangent line to the graph of f of x equals x squared plus 3x plus 1 at the point 0 comma 1. Okay, and write your answer in the slope-intercept form of the line, y equals mx plus b. All right, so very first thing is we're going to need to find the derivative at 0, right, at this x value right here, the x value of the point that they give us. That's going to be a in this case. All right, so the derivative of x squared plus 3x plus 1, right, is just 2x plus 3. Okay, so then what we want to do is plug 0 into that, and when we plug 0 into that, we simplify that out and we get 3. So the derivative of f at 0 is equal to 3. So that's going to be the slope of the tangent line. So here's our formula for the equation for the tangent line. We know that f of a is 1, right? That's just the y coordinate of the point that they give us. In some problems, they'll only give you this first coordinate, but it's easy to find the second coordinate. If they give you the function, you would just plug it in here. So notice if I plug in a 0 in here, I get 1, right? So that's the y coordinate there. So 1 is the y coordinate of the point that goes in there. 0 is a, that goes in there. And then the derivative at 0, which we calculated to be 3, goes right in there. So that's an equation of the tangent line. All we need to do now is to simplify that and put it in the slope-intercept form like the problem asked. So here I just simplify the right-hand side and get 3x. And then I add that 1 to both sides, and I get y equals 3x plus 1. All right, so the equation for the tangent line is y equals 3x plus 1. And we can take a look at the graph of that. And you can see here's the graph of that parabola, f of x equals x squared plus 3x plus 1. And here is the tangent line, 3x, y equals 3x plus 1 graphed out right here. This is a good way to check your answer also. If you have the equation for f and you have the equation for the tangent line, if you graph those out and take a look at them, the picture should look something similar to this in most cases, where the tangent line just comes and skims along here, along the parabola. It won't look like that in every single case. Sometimes it will kind of cut through at a point, so it just kind of depends. But for the most part, your picture should look like this. If it obviously is not just tangent, just touching it at one single point, right, locally around that point, then you know you've done something wrong. And so that's it.